Okay, so question 6 shows you an exponential problem, and we'll go through that in a bit of detail. The first part, so I'll try to just, you can pause the video and read it for yourself because there's a fair bit of language here. So do that and I'll come back. All right, assuming you have paused it. The first step is to show that A sub 0 is equal to 100, and it says at the time of death, the plant has 100 units of carbon-14. So this is sort of classic, it starts to decay at T equals 0 effectively. So at T equals 0, that power becomes 0. Anything to the power of 0 is 1. And so because the amount is 100, A sub 0 equals 100. Okay, that's no dramas. That's pretty stock standard sort of kind of way that part A is done. It's only worth my mark, and you can see why. Part B is to show that given this information, that the time taken for half of it to decay will be is known to be 5730 years, show that this is true. And you can see the 5730 is here. I'll briefly show you the mark scheme, but again, it's a log manipulation question rather than anything else. So you've got 50 equals, so 50, the amount of carbon left because it was half of what it starts with. So 100 divided by 2 is 50. So 50 units would be left. And then you've got 100 e to the negative 5730. Divide both sides by 50 to get that, and then take the natural log of both sides. So remember that the opposite of a base to the power is to take log to the base. So log to the base e is ln, or the natural log. So take the natural log of both sides and you get that there, and then there's a solve. Which is just manipulation. Don't need to do anything. It's not even a calculator operation, just solve. It's question 4, which part C, that I thought I'd just quickly show you. Find correct to the nearest 10 years the time taken after the plant's death for 25% of the carbon-14 to decay. So the tricky thing here is to recognise that if 25% of the carbon-14 has decayed, then that leaves you with 75%. Okay, so you're left with 75 units given that A sub 0 is equal to 100. So we go here and you can see that, that's what I basically said. So your equation becomes 75 equals 100 e to the power of, we worked out what k is already, ln2 over 5730 t. And it says here, you can see there are two solutions: using an appropriate graph to attempt to solve for t, or manipulating logs. Personally, I would be manipulating logs. So I would take ln of both sides, and that will give me this. Excuse me. Divide both sides by 100 and you get 0.75. So there it is there, 0.75. Take the natural log of both sides, which means that this power, I know it's a complicated expression, but that's the power, ln2 over 5730t, comes down because the e and the ln cancel out, and we're left with ln 0.75. So on my calculator, and this is the bit I just wanted to show you really, is that I would take the natural log of 75, so there it is there, control ln of 0.75. So that's the left-hand side, and then I'd multiply it by the denominator here, 5730. So that would be multiplied by 5730, and then I'd be dividing the numerator, which is ln2. So divided by control ln again of 2, press return, should get me a negative number. Get negative 2378. You can see there's a negative there, negative t. Divide both sides by negative 1 to get 2378.164, as you can see is the answer there. It says to the nearest 10, so that would make it 2380. So that's it. So I just wanted to show you how you can use the calculator button to solve that using natural logs. That'll do for this one.